Therefore, I am thinking I have to contribute something to you.
Yes, sir, definitely, sir.
So now it is visible.
Not yet, sir. Visible, sir.
Okay. So this is the empty cards data. And AM is the dependent variable. And these are the independent variable. They are called the factors. And I have to find out that is whether these factors can classify the AM into different groups properly. I can click the model. Model is nothing. Then is options. Frequencies. Options. Maximum iteration 20. Delta. Estimate. Okay, can save. Now I click OK.
Sir, output screen is not shared, sir.
Because the data is insufficient. I have to consider some other data. This is the output data. SS is 32. AM is 2 category. MPG 25. So insufficient memory it shows. So this is not a good data. I have to find out some good data. This happens when you have not good data. There is VS. Okay, let it be, let's try. Regression. Log linear general. Okay, now I am sharing. This is clear now. So first you go to the analyze, and there is log linear. That is a general. After that, logit. You click the logit. Then your dependent variable is gender. And this is your independent variable. Oh, it says it can accept the 9 variables. So it cannot take more variables. Acha, go to the Google Classroom. There I have written the logistic regression. Shubham, can you read the logistic regression? Okay, Shubham, please read. I am sharing. Shubham, are you here? Farah, is Shubham here?
No, sir.
Okay,
Sir, Amit and Kavita, they are here, sir.
okay. So, Kavita, can you read?
Good evening, sir.
Good evening, Kavita. Please read.
Theory. Logistic regression is a statistical method used to predict the outcome of a categorical dependent variable based on one or more predictor variables. It's an extension.
Have you shared it, sir?
Is it clear?
Sir, have you shared it, sir? Because it is not visible on the screen.
Oh, now it is clear.
Yes, sir, it is visible now.
Okay, Kavita, please read.
It's an extension of linear regression, but instead of predicting a continuous outcome, logistic regression predicts the probability of an event occurring.
Okay, so in case of the logistic regression, the dependent variable is categorical. But in simple regression, the dependent variable is continuous. Next.
Keywords: dependent variable, the categorical outcome variable being predicted. Independent variables, the predictor variables used to predict the outcome. Odds ratio, the change in odds of the call. GLM bracket formula is equal to AM MPG plus 8G, comma, family is equal to binomial, comma, data is equal to empty cars.
এখানে যেটা দেখাচ্ছে, so here you can find out that is the GLM. Okay, general linear modeling. Formula equal to, so this is the code. In case of the Art Studio, it is the code that AM is your dependent variable because AM is the binary. AM is the binary variable and then tilde MPG plus HP. So these two variables are there. They are the predicted variable. AM is your predicted variable. And comma family equal to binomial. Why it is binomial? Because AM is the binary data. And data is the empty cards. And this is the result. After that, so this is the result. And here we find it is significant. Significant. And after that, so these are the output. Interpretation. So this is the log odds of the outcome when all predictors are set to 0. So that is the intercept. This is the outcome. It is written 12.70. So
Yes,
this is if we consider that all the predictors variable, their score is 0, then we can consider the intercept is 12.70. So that is the intercept. When MPG and HP are 0. However, as cars can't have 0, MPG or this coefficient is minus. MPG is minus 0.31. This coefficient indicates that for every unit increase in MPG, the log odds of having a manual transmission decrease by 0.31. That means if MPG is increases, and you will find that is the AM is decreases because it is negatively related. Higher MPG is associated with a lower probability of having a manual transmission. A manual transmission is basically the AM. HP again, it is negative. This coefficient indicates that for every unit increase in HP, the log odds of having a manual transmission decrease by 0.05. This means that higher horsepower, HP means horsepower, is also associated with a lower probability of having a manual transmission. So now we can show this data in RStudio so that
Sir,
we can.
Understood, sir. Can you just explain once again, sir, what is the difference between linear and logistic? Only the categorical variable.
What happened, Amit?
Sir, are you able to hear me, sir?
Yes, the two variables are there. They are the two predictors, MPG and HP. And the predicted variable, basically the dependent variable, that is the AM. AM is measuring the manual transmission. So if manual transmission, yes, then it will be 1. If not, then it will be 0. Okay, now they are studying, that is whether MPG and HP, mile per gallon, and HP is the horsepower. These two variables, they are related with each other. So whether these two variables can predict the change in the dependent variable is binary one. That is the AM. This is the binary variable, and whether they can cause any change or not. That is the main thing.
So, sir, difference in the logistic and the linear is only the categorical variable. Every other thing is the same.
We have to check the relation between. First, we have to write down attach.
सर कुछ दिख नहीं रहा है स्क्रीन पे.
Not
Oh.
visible.
सर जब हम ऑड्स रेशियो बोलते हैं इसका मतलब क्या समझें? ऑड्स रेशियो.
Odds ratio, it indicates that is one unit of odd ratio, how many changes occurring in the dependent variable. For example, in simple regression, what we have understood, that is one unit change in X variable, how much change is in the dependent variable. Like that, this is the odds ratio. Odd ratio indicates that one. So I am writing attach empty cards so that I do not write repeatedly empty cards $. After that, I am writing result equal to GLM. GLM means first will be AM, then MPG, plus HP, comma, family equal to binomial, comma, data equal to empty cards. So now I am writing summary bracket result. Oh, so this is the data. So we have to find out whether there is any significant effect or not. We find that both MPG and HP both have the significant effect. So if we write down result dollar residuals result dollar which values are fitted so we can get that these are the cards and to what extent they are fitted. So this is the advantage of this model. So what is the relationship between HP and AM? It is 0.59. And here it is HP MPG and HP, they are negatively correlated. Now the result, dollar, if you want to find out the residuals, that is the deviation. Again, that you can get it. For each car. And if you want to find out the result dollar, coefficients, so this is the coefficient. Now, if you want to get more, result dollar, effects. So we can get the effect of each variable, MPG and HP. And this is the intercept. But I do not know why SPSS does not follow. Where lies the problem?
सर ये एम्प्टी कार्स वाला डेटा अगर एसपीएसएस में फेच करना हो तो कैसे करते हैं?
It's not coming. I do not know why. Log linear, it is the general. But I am talking about the analyze. Log linear logit. This logit model will be there. But I do not know why it is not working. Is it visible? SPSS is visible to you?
No, sir. No, sir.
I do not know why SPSS. You have to go to the analyze. After that, log linear. And there you can find out the logit. That is another one is the model selection. This is not important. You go to the logit. Then is the options. Then I click OK. Yeah, now it works.
सर ये जो एम्प्टी कार्स वाला डेटा है ये हम एसपीएसएस में कैसे पा सकते हैं?
You have to write down write.csv, next empty cards, comma file equal to within double inverted comma empty cards.csv. Then it will go to the CSV file. After that, you can use it in MS Excel.
ओके सर, थैंक यू।
So this is the output file. Is the output file visible?
नो सर।
So this is the output file. Now it is visible. Now you can get the convergence. Next is the goodness of fit. So this is the measures of association. Analysis of dispersion, goodness of fit.
सर इसको रीड कैसे करेंगे, क्या समझें इसमें?
One sec.
Sir, can you just repeat the things actually in the logistic regression? I am not able to understand what is happening.
There is one classification matrix but I am not getting the classification matrix. I do not know why I am not getting. That the likelihood ratio is significance level is not there. Goodness of fit, it is written value likelihood ratio. This is not clear. Why the goodness of fit 0? Okay, let Bhaktiyar sir will join. I think that is better. Bhaktiyar sir will teach. But only thing that I can share to you that logistic regression we can use when our dependent variable is categorical and independent variables are metric. At that time, we can do this. And I'm not sure, that is why in my SPSS, I am not getting the some other parameters. This logit, and logit will be your program, and this dependent variable will be kept here, and the independent variable will be here. And these variables will be, these independent variables will be correlated. At least the results show that is the measures of association is not very good. The result shows, because I am not sure. Let Bhaktiyar sir join and then we will talk. Okay.
Okay, sir. Thank you, sir.
Okay, thank you. I think on Wednesday, Bhaktiyar said we'll take the class and he will
Sir,
discuss.
today's class, please summarize, sir. I am not able to understand.
Okay. Okay, thank you, Amit.
Sir, can you summarize?
Yeah, you can leave now.
No, sir. Actually, I am asking to just summarize the things. I am not able to understand today's class.
Summarization is that logistic regression will be applicable when your dependent variable is binary in nature. That is it will be the categorical in nature, and independent variables are metric. Then you have to find out that is whether the independent variables can predict the change in the dependent variable or not.
In linear regression, they were all continuous, sir.
Yeah, in case of the linear regression, they are continuous. But here it is binary. For example, past tail. Past tail is the binary.
Sir.
I'm not getting. What are you telling?
Same thing we have seen in the Manavana, sir.
MANOVA.
One was
No, it is
categorical.
not related to the MANOVA.
Okay.
This is not related to MANOVA. It is the regression. Okay, Farah, please call the next batch.
Yes, sir. Sir, you please stop the recording, sir.
Yeah, thank you.
Yes, sir.